All right, so we're starting chapter 7 today then, simplifying radicals. So we're going to evaluate some radical expressions, simplify the radical expressions by extracting the roots from the radicand. We're going to apply absolute values to the simplification of even indexed roots. And we're going to find the area of a triangle using Heron's formula. So there's a lot going on. All right, so the chapter starts off with talking about when you might use this. So to determine the proper dosage of medicine, doctors calculate the patient's body surface area. I don't know if you ever knew that. Your BSA, okay? And so it's this formula here that has the radical in it. Correct. Mm-hmm. Yep. So where W is their mass in kilograms and H is their height in centimeters. So it helps them decide how much, what dosage to get them. Do what? Yeah, because you're a smaller guy. This is true. So anyway, that is a time like Mrs. Shipley, right, was a pharmacy tech and worked at the pharmacy at Hy-Vee and different things. So that might be something that she would even be familiar with and have to verify some doctor's prescriptions or things. Drug addicts might know that. This is true. So for any real numbers, a and b, and any positive integer, n, if we take a and raise it to the power of n, then it's going to equal b. So a is an nth root of b. These are opposites. They undo each other, just like multiplication and division. The square and the square root are, okay, that's what we're doing. So the radical sign indicates a root, and the expression under the radical sign is called the radicand. So I want to take and let's label these things. So what is the b here? The radicand. Okay. Uh-huh. Radicand. He's been canned. Okay. What's this number up here called? Not the radical. Not the radicand. That would be kind of funny. All right, that was one if you knew it. This is called the index. Okay, so the index. And what's this thing called here? Not the square root. It's the radical sign. This is the radical sign. It is radical, dude. I would agree. All right. Radical sign. I could put dude over here. Dude. Okay. All right, I like it. It'll work. All right, so these are the opposite, okay, is what we're talking about. So it's a little harder to see with the square root because we don't ever write the 2 up here. Well, that's an ugly looking 2. We don't write the 2 in the radical sign, right? If there's no number, then we assume, if there's no index there, then it is a square root. Otherwise, okay, these are the opposite. They undo each other. They're just like the square and the square root. If 3 cubed equals 27, then the cube root of 27 is 3. So we have 3 to the power of 4 is 81. Well, we say, oh, well, then we're going to take the 4th root of 81, and it's going to take us back to 3. You're taking what you already knew. Yep. Because, right, this was 3 times 3 times 3 times 3. So when we want the 4th root, it's the 4th root of 3 times 3 times 3 times 3. Before, when we've done the square root, remember when we say the square root, when there's 2 of them, we can pull them out. Well, that always depends on what number the index is. So here there's 3 4s, so we can pull that out, and our answer is actually, thank you, there's 4 3s. Yes, you got it. Okay. Got nothing. Okay, so then the number and nature of nth roots varies. Okay, so only real number cube roots of negative 27 are the only real cube root of negative 27 is negative 3, since the quantity of negative 3 cubed equals negative 27. Yes. Okay, so it's when we had a square root, that was with square roots, right? we couldn't do the we couldn't find the negative of a square, or the square root of a negative number, unless we get an imaginary number, which we can still do. But in this case, because it's a cube root, a -3 times a -3 times a -3 would equal a -27. So that's what we're getting at here. When our radicand, so the number under here, I'm going to put a big R there, right? That number under there for your radicand. Well, I guess it's a B. Maybe we should put the B under there. Okay. Okay, when your B is greater than 0, when it is 0, and when it's less than 0. Okay, then we have when the n is even, we're not going to have any roots. But when the n is odd, we're going to have one negative root. That's what this is an example of. So you might want to put in here the cube root, or let's see, the cube root of -27 is there. That fits in that category. Then it says both 3 and -3 are the square roots of 9. Okay, because we could have -3 squared is 9 and 3 squared is 9. So 9 is my radicand. Okay, so that's this number here. Okay, when it's greater than 0, it's going to have one positive and one negative. So this is when the n is even. Yes, when our index, sorry, let me put this here. When our index is even, so here we had a square root. So that's that example right there, the square root of 9. How do I get a positive number both times? What do you mean? Okay, you mean like if I did, so -3 times -3, negative times negative is a positive, and then 3 times 3 is 9. So this is why we would write like plus or minus 3 is the answer there. That's one way we show it's both of them.
Because the two negatives cancel. Anytime you have two negatives multiplied, they cancel. Like you cancel.
That makes sense so far? Okay. All right, when n is even, the radical sign indicates the non-negative or the principal root. Okay, so it's called the principal root is the non-negative. Okay, so the square root of 9 is 3, and the negative square root of 9 is 3. But the principal root is 3, no matter which way we write it. Okay, then there are no real square roots of negative numbers. This is what you were kind of talking about. Okay, there are no real square roots of negative numbers. The square roots of negative numbers are imaginary. Okay, so we have that plus or minus 3i, which we have talked about. So good job bringing that back in. All right, so let's look at example 1 and find each real number root.
So A and B are both going to be imaginary.
A and B are both going to be imaginary. Well, not necessarily, because
since the name, I thought it was just saying that there's no real
square root. This is a cube root. So that goes back to, first of all, B. So my B here is less than 1, or less than 0. So B is less than 0. And my N is odd. So my answer, I should have one negative answer. It would be -5. Because -5 times -5 times -5 equals -125. So the cube root equals -5. That is correct. Totally guessed. Well, you guessed correctly. And let's see, I'm going to write this equals -125 down here so that we have room to do the next one. All right, so the next one, we have the fourth root. So our B, first of all, is less than 0 again, right? Because it's -16. Our index, or our N, is even. So we got nothing. There is no root to that number.
not even like plus or minus 2y?
Nope. We just put none. It does not have an nth root. Okay. Question so far. That's not a hand, that's a stretch. Okay. How about C? So our B is greater than 0. Yep. And our N is, there's even, right? Because it's a 2. All right. So B greater than 0, even. I should have one positive and one negative.
So it's going to be negative 0.4 and positive. It could be plus or minus 0.4.
It could be plus or minus 0.4. Correct. Okay, so then what would be the principal root here?
Is it 0.4 or is it 0.0?
0.4, because when we do 0.4 times 0.4, we would get 16, and we move the decimal 1 2 places over, so it'd be right there. That makes sense? Okay, yeah, if you pull those back.
So you said the principal root?
Yep, what's the principal root here?
0.4.
Remember, the principal root just means the non-negative root. So 0.4 is the principal root. Yep. Like, I wasn't trying to be a smart aleck, but if it said principal root, you don't list both of them. You just list the positive one. Okay? It did not. I'm just saying, like, later on. If you on your homework, it says, what's the principal root? It's the one that does not have the negative to it. That's all. Okay, let's look at D then. Okay? What's your B for D, the 27/8? Okay, B is greater than 0. And our N is odd. So for greater than 0 and odd, we should have one positive. So this one we have to break down to the cube root of 27 and the cube root of 8. So I heard it was 3 and 2. Good. All right, the last one. The square root of 100 million. So B is greater than 0. Our just a little bit. Our N is what? We don't care if it's positive. We care if it's even or odd. Even. Okay, good.
Is it 10,000?
It should be 10,000. So plus or minus 10,000. Again, so what would the principal root be? 10,000. Okay, good. Very nice. All right, questions over those?
When does it get bad? Because so far it's too easy to all be good.
Well, I don't know that it's going to get bad at all. Let's look at the next one. The product property of radicals. Not so much. Okay, so if we're finding the nth root of x and the nth root of y are real numbers. The nth, N-T-H. This is an n. This is the nth root of x. Okay, and the nth root of y are real numbers. Then the nth root of xy is equal to the nth root of x times the nth root of y. All it's saying is we can split this up, right? So we have the cube root of 8x cubed y squared. Well, we can say this is the same thing as the cube root of 8 times the cube root, are you okay, of x cubed times the cube root of y squared. It applies to all of them. You don't have to write it out like this, but this is how we're going to start to make sure you understand it. So what's the cube root of 8? 2. Okay, the cube root of x cubed is x, and then y 4. Do we understand how we got there, though? or do we need an intermediate step?
So we just split it up. And then
Because this is the same thing as 2 times 2 times 2.
8x cubed be one term though?
Wouldn't what?
Wouldn't 8x cubed be one term? Like in the original equation you say.
Like, yes, but it is one term when we call it, like when we're talking like monomial versus binomial and things, it is one term, but the cube root applies to each part of the term, just like when we do division. We're applying, like we can apply it to each part of it. So, or like when we were factoring the polynomials before, right? Trying to get them, like when we had 8x cubed plus, I was trying to think of another, whatever it was, like say we had d cubed, and we were trying to get it in that form to see if it was the sum of cubes or the difference of cubes, and I said, well, we have to find the cube root of this, so that it was 2x cubed plus d cubed to get them both in that cubic form. Do you remember how we talked? So it's the same thing. This cube root applies to everything. And then, so when we do the numbers, we have to see how many are here. But again, like how many x's. When we have this out here, we're really taking the exponent and dividing it by 3. We can look at as kind of a shortcut. So like 12 divided by 3 is 4. Or how many groups of y cubed? If it's y to the 12th is under here, well, that's y cubed times y cubed times y cubed times y cubed. 3, 6, 9, 12. So we could say, oh, that's the same thing as y to the 4th. We had 4 of those.
so with exponents you just divide.
Yep, with exponents, you just divide the exponent by the index. Because 3 divided by 3 is 1, 12 divided by 3 was 4. So you could write it a little closer together if you wanted, but that is correct. So with the next one, we have the 4th root. So we're going to take the 4th root of 81 times the 4th root of a to the 16th times the 4th root of b to the 8th. So how about the 4th root of 81? 9 times 9 is 81, right? So that's only the square root. 3. Yeah, because 3 times 3 times 3 times 3. So there's 4 of them, so we can take that 3 out. So we're going to have 3 times, okay, let's do that shortcut. What's 16? We're going to take the exponent and divide it by the index. 16 divided by 4 is? 16 divided by 4, oh, okay, it's 4. And then 8 divided by 4 is?
It's Pikachu!
8 divided by 4 is 2.
They said A. I'm like,
So 3a to the 4th b squared is the simplified one there.
and then you still have to do that. Or did you still put the radical sign there? Or not? Because you already did it. Like that's your answer.
This is my answer. Yeah, this is me doing the work of the radical sign. Good question.
So you solved it.
Yep, so I solved it. Or in this case, I simplified it. But yes.
That's with the negative.
Okay, so this next one is a negative number, right? So our b is less than 0, and our n is even. So can we even do it? We cannot. This one has no real root.
What if it's just a variable?
In the index? You mean like up here?
If it was C 12.
Then you could do that. The square root of c to the 12th.
But you don't know if C is not.
Well, we're not talking about c. When we're talking about n, n is the number up here, if you recall. N is the index. Oh, if it's just a variable, because you still don't know b, so yeah, you would just say it was c to the 6th. I see what you're saying. We would assume it was positive.
Oh, okay.
Yeah.
Just assume
Yeah, we just assume that it's positive. I see what you're saying. Yes. Okay. So is it terrible yet? Okay. There is some more work coming on. Heron's formula is probably the worst part. The Heron's formula at the bottom. All right. So then we've got the nth root of x to the n. Yeah, there it goes. Okay. Or we've got it here as the nth root of x to the n is the same thing. So is going to be the absolute value of x if n is even, and it's going to be x if n is odd. So here's the thing. The absolute value must be used when an even root, okay, when an even root results in a variable to an odd power, presenting a negative value, which would not represent the principal root. 139 set or not, yeah. 1 3 5 7 9. Yeah, that kind of odd power. Not odd otherwise. So I do like it though. All right. So let's look at this one. The square root of 25. Nice. Okay, so we got the square root of 25 is what? 5. And the square root of x to the 14th is? Okay, maybe I don't need parentheses. Okay, so I've got x to the 7th here. All right, so this is saying the absolute value must be used when an even root, so we have an even root, it's a square, results in a variable to an odd power. This has a variable to an odd power, so we have to use the absolute value there. That's fair. Like you need to remember it for the test, not for eternity. So file it in your short-term memory. You wish it worked like that. Okay, so then let's look at the next one. So we've got a negative on the outside. Okay, we'll keep that in our answer. But we're going to do the square root of 49 and times the square root of y squared times the square root of z to the power of 12. So what's the square root of 49? No, it's just going to stay. It just stays in the front outside. It's not being distributed. We have to do what's inside or underneath the radical first, just like in parentheses. We do all the stuff in the parentheses first and then apply the negative.
Well, I mean, you would write the negative outside of the y.
Okay. Yeah, so it's going to be negative 7, I heard. What's the square root of y squared? Y. And what's the square root of z squared to the 12th? 6. So z to the 6th. Where? Nope. The negative. We only need one negative. Okay. Where do we need the absolute value? On the y. Okay. So we have, because we went from, it resulted in an odd power. This is y to the first. So we have to have that in there. So it's negative 7, absolute value of y, z to the 6th is your simplified answer. Okay, and our next one. So we've got the 4th root again. So the 4th root of 1/16. Well, actually, let me back up here. That's not where we should start, really, on this one. Should we? Where should we start on this one? Wherever I tell you. I like it.
So, oh dear.
Okay, we could, I mean, all right, we can go back to where I had before. So the 4th root of 1/16 times the 4th root of r to the 8th